Hello, Algebra 2 class. Hope you had a nice Thanksgiving. I'll be having surgery on Monday and having follow-up appointments on Tuesday. So I won't be able to be with you online at least for Monday, possibly into Tuesday. So since I won't be able to be with you, what I'm going to do is give you the lesson by video. So you're going to be watching this video, and then after the video, you're going to be doing a worksheet. I'm sure that's your favorite thing to do after a nice long break. So the first things we need to do is probably just review what we had covered in that last session before break when I had you take notes, and where your only homework over break was to review those notes so that you'd be fresh as you could be from not having actually done things for a week. So first thing we did is we talked about slope. Slope can be calculated if you know the coordinates of the 2 points. It's rise over run, which essentially means it's this formula right here. You take one y coordinate and you subtract away the other y coordinate, and you divide that by x2 minus x1. Doesn't matter which point you start with, which one you call point 1 and which one you call point 2. What matters is once you choose an order for the y's, you must stay consistent for the x's. If you remember right, we also said that this calculation that we get would be represented by m in any formula to do with lines. Okay, so if you have a graph and you're trying to find out the slope, if there's a grid, I had a line going through this point and this point, sure I could find its coordinates and I could use that formula. I could find the coordinates of this point. It's 0, -1. I could find the coordinates of that point. That's 2, 3. And then I could use that formula. But there's an even quicker way to do it if it's on a grid already and you don't have to do a lot of calculating. You can just count how many boxes you go up. So that would be 1, 2, 3, 4. That's my rise. And then my run would be 2. Okay, so that slope came out to an integer, but a lot of times it will not be an integer. If it isn't going to be an integer, please don't turn it into a mixed numeral or a decimal. You would want it expressed as a fraction. Okay, certainly you could call that one 2 over 1. Couple other things I want to mention. You can count boxes, but make sure you don't skip over the axis itself, because that's 1 unit to get to here. 2, 3, 4. So some people get 3 because they're counting tick marks rather than counting this as a 1 unit going up. Okay, so either visually or you can calculate it with that formula. Keep in mind it's a measure of how steep a line is. So when you walk from left to right, this would be a very steep line. If we walk from left to right, this would be a very shallow or not very steep line. And basically, the more tilted it is, the steeper it is, the higher the number is for its slope. So if I went over 1 up 10, that's a much steeper thing to rise 10 and go over 1 than if I had just risen 1 and went sideways a whole lot. So the bigger the slope, the steeper the line is. And we had 2 special circumstances that came up. We had the circumstance of what if you had a horizontal line? Well, the rise going from any point to any point is not at all. And the run is whatever number you choose to go. In this case, it was 3. But that fraction, whether it was a 0 over 3 or 0 over 4 or whatever, that fraction would be equal to 0. So we talk about a horizontal line having a slope of 0. I sometimes exaggerate it this way so that you can see the zeros right in the word horizontal. The other thing is some people actually know which way it goes, but they forget the words, horizontal and vertical. If you look out on the ocean and you're in a little boat and you look where the sky and the water meet, it goes sideways. So that is your horizon. So horizontal always means side to side. With a vertical line, I rise whatever. In this case, I rose 2, but I could have risen any amount. And then I run sideways 1, not at all. I don't move sideways, that's why I'm still oriented vertically. And you can see that that doesn't produce, this number is not equal to 0, because 0 times 0 is not 2. In fact, nothing in the world times 0 gives me 2. So this is not even a number. So if I talk about it having no slope or an undefined slope, that's the vertical case. So vertical means up and down, and it does not have a slope. Even though it can have a graph and have an equation, it's its slope that doesn't exist. So that is the brief reminder of what we did in a good chunk of the last class about slope itself. If a slope is negative 4/3, you can assign the negative sign to the top of the fraction, or you can assign the negative sign to the bottom of the fraction. All of these are the same number as each other. So when you come to graphing, if you were graphing, a rise that's negative is actually a drop, and then you run 3 to the right because it's a positive run. If you were using this, you rise 4, but then you go leftward 3 because you have a negative run. So basically that's how you would handle a negative slope. Okay, what do you need in order to graph a line? If you remember right, it's the same information that you need to write its equation. You need to know where is the line located and how does it tilt. So if I said write, or graph, I should say graph line through 6,1 with slope 1/3, I would first graph the point 6,1, and then from there I certainly can move up 1 and over 3 more. Measured from here, I rise 1 and I run 3. So basically the slope is how you move to get from one point on the line to another point you're sure is on the line. And then it's just a matter of lining up your ruler. So if you know a point on a line and you know a slope of that line, you have enough information to graph the line in the right location and with the right tilt. I should mention most of you are used to graphing from y equals mx plus b. If you were given a formula in this, an equation in this form, like y equals 3x minus 1, just identify the slope and the y-intercept. Always graph the y-intercept first. And then from here, express your slope as a fraction, and that top number is your rise. So I rise 1, 1 tick mark would actually be the axis. So from here, I go up 3, and then sidewards 1, and that's the line. So if you're given an equation, and it's in this form, And by the way, what I mean by in this form is with y being by itself and there being no y's over here. So sometimes people will take an equation and rearrange them until the y is by itself and the x and the number terms over on the other side. And they can identify the slope and y-intercept that way. Okay, so long as you know a point, like the y-intercept in this case, and then the slope, you can get that line in the right spot. Notice here, there was no reason I had to use the y-intercept. I wasn't told the y-intercept here. So basically, just go find any point that you're certain is on the line, whether it's just an ordinary point or the y-intercept. But the slope is measured from where that point is. You rise and run the proper amount. So that's your quick lesson on graphing using a point and a slope. So now we're going to look at what we actually spent the rest of the time that Friday or Thursday before break, which was writing equations. So basically, with writing an equation of a line, you're being given the description and you're coming up with the math rule that would produce a line that fits that description. What we did with graphing just a second ago, we were given the equation and we were going to a picture. Here, we're going to information or from a picture and we're going to the equation. And the equations that I said you would use the most, the form would be this, called point slope because that's your slope and that's your point. This is what you should have reviewed for homework. And you use this every time you have a point and a slope, or maybe when you have 2 points and you have to first calculate that, but then that goes in for M. And you choose just one of your points to put here. You don't put both sets of points in there. And then, to a lesser extent, the slope-intercept, which should probably be called slope, comma, y-intercept, or slope dash y-intercept, because it's not just any intercept, it's where it crosses the y-axis. That would be this. A lot of people graph from this form by choice, but as far as writing equations when you already know the graph or its description, we only use this when we're told the slope and the y-intercept. And then finally, the last 2 equations were x equals some number. I'm going to refer to the number as just c for some constant, some unchanging amount, or y equals some constant. This was for x staying constant, means every x is the same, so it ends up looking like a vertical line. And y equals some constant, if it was like y equals 1, I'd go find a point that's 1 unit high, and then I go find all the other points that are 1 unit high. So basically, when you draw the line, if it's vertical, you go put a mark on the x-axis, but then you make your actual line a right angle to where you put the dot down. Okay, so horizontal lines always have an equation in the form of y equals some number. Vertical lines always are in the form of x equals some number. But almost all the time you're using this formula, and you use these only in their specific circumstances. One thing I want to mention is when you're watching a video, if you think you missed something you didn't quite catch that, drag the progress bar a little far back and then listen to it again. You don't have to watch the whole video again, just catch that part you missed. And if you're writing something down or something got clarified and you're making markings on your notes, pause it so you don't miss the next thing that's being talked about. So that is your review, more or less. When we wrote equations of lines the other day, back before break, we had several different cases that we had. So if I gave you a point, 3, 8, and 3, 7, most of the time when you have 2 points, you will go to that formula to find the slope. You can go 8 minus 7, make sure the y's go on top, but once you establish an order for the y's, choose the same order for the x's. And I recommend anytime you get either a 0 or an undefined. It doesn't even matter to me which one. If you get a 0 in the top or the bottom, it means you've got one of these two special circumstances. And as far as writing equations go, just look back at your 2 points. It looks like the x is not changing. So the whole equation is x is staying equal to 3. Okay? Do not try to use this formula for a vertical line because there's no way to plug a non-number, a non-existent number in for m. So you have to go right to this form right here. Most of the time when given 2 points, this kind of thing won't happen. So for instance, 3, 1, and 5, 20. If I wanted to know the slope there, I would just take one y minus the other y. Again, I could have gone 20 minus 1 or 1 minus 20 and it wouldn't have mattered. But when you go to put the difference of the x's on the bottom, stay consistent. If I start with that point for my y's, start with the same point for my x's. And you get 19 halves. If this reduces, feel free to reduce it, but do not turn it into a decimal. Do not turn it into a mixed numeral. Leave it as just a regular fraction, something over something. If it happens to be an integer, go ahead. If it were 18 over 2, call it 9. Okay? So that would be an example of using this formula. The slope intercept would be like if I gave you the slope equals 3 and the y-intercept equals 7. That's about the only circumstance that I use that, because I put the m right there and I put the b right there. That's what the b stands for, is the y-intercept. Let me make that into a plus sign. There's my answer. Real quick. Plop, plop. So that would be the equation. But don't do that with another point that isn't on the y-axis, because it has to be the y-intercept if you're using that. Okay. These are things we all went over. These should be in the notes that I told you to take last time, and in the notes that I asked you to review the night before you come back to school. So if I gave you slope 4/3 and the through a point, (619), you can't put this in for B, because this is not on the y-axis. The reason we know it isn't is that's not a 0. So this would bring me back to this. So y minus y1 equals m times x minus x1. Most people go right to the equation if they are comfortable with this, but in the beginning, if you're feeling a little like you're on shaky ground, actually take the time to write the formula. And now it's y minus the y coordinate of the point that I have is equal to the slope times x minus the x coordinate of that very same point. You're all done? That's all there is to that. So you use this in a rare circumstance if you're given the y-intercept and you're given the slope, but all other times you're pretty much using this unless you're in either a horizontal or vertical kind of situation, which always takes these particular forms. Finally, parallel lines have the same slope. So if the slope of this is, say, 4/5, and if these are parallel to each other, meaning they never cross, then this would have a slope of 4/5. And if I had a line that was making a right angle with one of those, you would flip its slope over and change its sign. That's called the negative reciprocal. So when two lines make a right angle, they don't have the same slope. They have negative reciprocal slopes. Now, why would you need to know that? Well, if they're having you write an equation of a line, and they don't tell you the slope of the line, but they give you information about yet a second line, if you know that that second line is parallel or perpendicular to the one that you're trying to write the equation of, you can either borrow its slope or you can take the negative reciprocal if it's making a right angle. So that's pretty much the review on lines. I'm going to see what you can do from the worksheet. You might want to come back and listen to parts of this, but certainly the worksheet you should do during our class time, because I won't be there, but you should then finish the rest of it as much as you can for homework, and then upload it to Google Classroom. So I hope this little quick review was helpful, and I hope that the worksheet doesn't jolt you too much out of your vacation mode. So have a good day, and I'll see you soon after my surgery.